Hi, everybody. My name is Dominic Dabrowski. I'm a resident physician in occupational and environmental medicine over at Health Partners throughout the Twin Cities. And for NORA 2023, I would like to present some research done by myself and my colleagues. Now, before I get into the poster, I would just like to set a little bit of context. Our research has to do with biomonitoring of firefighters in various different districts who were fighting a fire specifically in February of 2020 in a place just about an hour north of the cities known as Becker, Minnesota. This fire went on for 4 days, and it was at a scrap metal yard. And the problem with scrap metal yards is there are a lot of potentially toxic substances that, if combusted and burned, can result in exposure to various substances that I will get into. Now, specifically, this was Northern Metals Recycling, and they had previously been in the northeast neighborhood of Minneapolis, and after a lot of political back and forth, they had finally decided to relocate their plant up north to this place. So if down here in the cities you see the Twin Cities campus, Becker is about 1 hour away. Now, this fire again was in February in Minnesota, so it was also very cold. That is potentially a complicating factor. It's not one that we'll touch on very strongly in our research, but it's just something to think about. Now then, I apologize for all that workaround. I'd like to go back to the actual poster itself. So here we have our research. So going to zoom in a little bit just for your viewing. So we were predominantly concerned with heavy metals and with polycyclic aromatic hydrocarbons, since those have both been proven to have carcinogenic potential in humans. And those are the things that we were potentially worried about as far as combustion of recycling material. Now, the things that were present at Northern Metal Works that were of particular concern were cars. Cars are made up of a variety of different substances. There's a lot of heavy engineering involved. There are gasolines and oils and other fluids in the engines and throughout the whole caddy. There's glass, there's plastics, so they are potentially very hazardous because of the sheer number of materials that are present in an automobile. However, there were also refrigerators, other metals, glass, foam, and insulation, just to give context and round out what we were dealing with here. Now, again, this fire raged for about 4 days, and various different departments were involved. I'll get into that in a little while. We were approached by fire chiefs, and they were asked for us to biomonitor their staff. This was done through urine and through blood samples, and we tested for specific substances that, again, I will get into in a little while. And follow-up was offered. However, as I'll get into a little bit later, not a lot of firefighters sought that follow-up. Now, what we had done was we had collected demographic survey data, things like age, gender, which fire department, how many years of service, how long they were physically at the fire themselves, and the duties that they had done. This is important just to be able to control for other factors, whether older or younger firefighters were more prone to be exposed, whether their levels were higher, just to give you a little bit of idea of what we were thinking. As far as biomonitoring, again, 24-hour urine is currently considered a gold standard with measurement to exposures. Spot serum and blood are also quite useful, so we collected that as well. And then we performed a few different tests. Complete blood count with differential, basic metabolic panel. Those are hospital standards, things that we test for patients for a whole variety of things, not necessarily just exposures, but it's good information to have, and they're relatively inexpensive to do. Heavy metals, of course, that's what we were interested in. And as you can see on this chart here, we looked for a variety of different metals. These are the things that we would most often expect to be in things like cars, refrigerators, ancillary metals, etc. So as you can see, with things like antimony, there's only a blood test that was reasonably available for us to do. With things like arsenic, we could do blood and urine, as well as bismuth. Again, only blood. Cadmium could do both. And as you can see, for the majority of these metals, we could do both, which is definitely helpful because it's sort of our fail-safe to make sure that we can help catch some of these things. If Let's say there was a bad blood sample, maybe the urine would pick it up, or vice versa. And again, this is just for the non-medical crowd to give a little bit of idea how medicine is done, the clinical thinking behind it. In addition to these metals, we also measured 6 different polyaromatic hydrocarbon metabolites, which I'll get to on a later graph. As far as metal biomonitoring here, we also tested for arsenic, which, as you can see, is here on this list. Now, reflex fractionation simply means if there is a high arsenic level overall, we tend to fractionate it into organic and inorganic, and as well as methylated. The reasoning for that is not all arsenic is what you think of when you think, let's say, one of those old movie jokes where the wife was poisoning the husband or what have you. There's only two kinds of arsenic that can be potentially harmful. Those are inorganic and some forms of methylated. Organic arsenic is not harmful. It's found in things like seafood and the soil. And while it doesn't offer any nutritional benefit, it also doesn't offer a means to poison somebody. So that's why fractionating is useful, because it can differentiate a high total from an actual poisonous subset. So just giving some more context there. As far as correction levels, so the level of detection was used. We would set it either at 0 or at greater than 0, and that's how we would differentiate it. For polyaromatic hydrocarbons, we have a nice chart here, and if you look at it quickly, you can see that there's a pattern emerging in the chemical structure here. They like hydrocarbon rings, and as you can see, some of them have a lot of hydrocarbon rings. That's actually part of the reason why they are potentially so harmful, because there's so many different rings and there's so many different stable rings, but potentially reactive offshoots that can lead to problematic metabolic derangement. And that's sort of how they do their damage, so to speak. These tests were done by the Minnesota Department of Health. There's a public health laboratory division and an environmental laboratory section. So pretty much these sorts of exposures are what they will deal with. Now, as far as some more of the nitty-gritty data, here's our results. We sampled 109 firefighters. We received a total of 99 urine samples. Some of the firefighters did not return giving the whole 24-hour urine sample, so we had to disqualify those 10 that did not. And then 41 samples were provided to Minnesota Department of Health for polyaromatic hydrocarbon analysis. And we were able to divide into the following demographics. So the mean age was 40. However, as you can see from the percentages, the distribution was actually pretty good. We had a variety of ages from 20 to 50 plus, without one truly dominating over the others. The same can't be said about sex. There was a vast majority of male firefighters. This is reflective, not exactly, but close to national trends of the amount of firefighters and the gender breakdown. So for our purposes, this was relatively useful. Nationally, there's a little bit more female firefighters than you see here, but we're working with what we have. As far as the things that were done by the firefighters at this Becker fire, you can see the vast majority either were working on fire suppression or they were the driver engineers, with about 14% left over doing command. Now, the reason why this is potentially important is because how much of an exposure did they necessarily have? If you're working on fire suppression, you're much more likely to literally be face to face with the fire and all the smog and fumes and other things that are coming off of the active fire. Whereas command, you might be a little bit more removed. So again, just some context there. As far as the characteristics of the firefighters, again, pretty good distribution here. However, more of the firefighters, a large minority, if you will, had 10 plus years of firefighting experience, which for our cases might have actually been beneficial, because it told us that more of the firefighters than not were not novices. They were experienced. And so if they did end up having exposures, it could tell us that it wasn't necessarily because they weren't wearing their mask right, or because they had a lack of experience or anything like that. As far as the amount of time spent on the fire, the mean was about 16 and a half hours. However, there were some that were on the fire for multiple days. And as far as days from exposure to lab, there was nearly a week. So that's important, because not all of these metabolites in all of these blood and urine, heavy metals are necessarily detectable for a long time. Some of them are cleared in a matter of hours or days. So that is a potentially complicating factor. However, we were working with what we had. Here you can see pretty much every metal had a few people, or at least one, who were above the designated maximum reference range. The ones of interest, however, where there was more than one or two, were chromium, which is helpful because those are present in things like alloys, electrical batteries, plating, and pigments, which are things that are done around automobiles and some of the other things that we talked about. Manganese was elevated in 26 of our samples, so a little bit more, and that has to do with glass manufacturing. So again, automobiles and glass were two of the things that were on fire, exposures of concern. And then selenium was elevated in serum, in urine, straight urine, as in single catch, as well as 24 hours. And then the ratio as well. A lot were elevated. And while not all these things apply to the things that we were worried about, chemical catalysts definitely were. Electronics were potentially concerning. Glass manufacturing and pigments, all of those things could have been present in the list of things that I had mentioned previously. And then we had two people with zinc as well, just to round out the list. Coatings, galvanizing, and paint. Now, the caveat is that these are also essential metals, essential dietary metals, and they could also be present from dietary supplements. There's not enough information here to decide whether or not there were a lot of people taking zinc or selenium supplements. So it's not something we thought about a lot because it's just not something we could have tracked down very well. But again, I'm just trying to be transparent here. Then there's also arsenic, which we have a separate table for because it's of particular interest. Now, again, we had reflex fractionation, meaning that if arsenic was elevated, then we looked into organic versus inorganic versus methylated. And as you can see, there's not many or almost no inorganic present in our sample, whereas there was a good bit of organic and there was also some methylated. So it's less likely that there was a straight chemical exposure to arsenic. And that's a little bit hopeful because the dangerous type of arsenic was not well represented in our table here. And then here were the PAH metabolites. So this was our level of detection. For most of them, it was 50. For a few of them, there was 10, and that depended simply on the individual metabolite. Some of the values were very high. So we certainly can't rule out that there may have been some polyaromatic hydrocarbon exposure. And that was something that we considered as well. Now, as far as what to take away from this poster, we did what was essentially a cross-sectional study. We did try to have follow-ups. However, we were not successful in obtaining those follow-ups. And that's generally a decision made by the firefighters. We were sure to communicate with them that they had that option. However, they may have not seen it as particularly important. They may have been busy with other things. Potentially, there was some lapse in communication. We don't want to speculate too much on that. However, we simply did not have follow-up. I just wanted to let you know about that. It does raise questions about recurrence and ongoing exposures in other fires too, potentially, because while not all fires are junkyard fires, there can certainly be structural fires, there can be natural fires, and we have to ask what sort of chemical exposures there are with those. With a fire like this, of course, inhalation is going to be the primary concern. However, even with heavy firefighting gear, an excessive amount of substances fuming throughout the structure can lead to skin absorption and even ingestion, depending on if the mask has perfect seal or not perfect seal. These are just alternative ways of thinking about some of these exposures. There weren't particular concerns about acute symptoms. However, that doesn't mean that there weren't chronic exposures, and we also need to think about carcinogenesis down the road. That's a chronic process which can take years, so certainly something to think about. There was also the thought of community-based participatory research. The reason for this is it's very tempting in academia to find a population and to do research and to get in, get out. and to put our studies together, put our results together, and get published. However, it's potentially disrespectful and not entirely fully informative if we don't involve the communities that we're studying. As a result, this is certainly something that we'd like to consider going forward. CBPR is not just a trend, it's probably something that's here to stay, and we at HealthPartners would like to be involved as much as possible. Now, again, this study was far from perfect. We had to do it on the fly pretty much. A fire happened to literally ignite, and we had to react on the spot. So the fire chiefs asked us while it was happening or after it started. We had to set up our study protocols and we had to go from there. And the whole thing was over in about 4 or 5 days. So in addition to it being fairly quick, we simply didn't have baseline pre-exposure, post-exposure measurements. We simply had to, as I said, follow a cross-sectional protocol because that's what we were given. And as I said, while follow-ups were offered, follow-ups were not taken advantage of. We had to think about variable duration because different firefighters were there for different lengths of time. And firefighters, as I said, were offered follow-up. Laboratory tests don't necessarily separate all the valence of metal components. So different metals have different half-lives and it can be metabolized differently. As a result, we might not necessarily have caught all the metals, or alternatively, our tests for catching the metals might not have been perfect. We have to definitely consider both of those things. Industrial hygienists were not involved in this project, which is something we wish we could have gotten to. Unfortunately, we didn't. The Minnesota Pollution Control Agency did monitor some of these particles, but they didn't look for specific compounds. So there was also a lack of differentiation for some of these things. So as a result, we had firefighters that were exposed to potentially hazardous chemicals for several days while they were fighting a fire. We'd certainly like to do more analyses. We have a fair bit of data. This is hopefully the first of several poster presentations or maybe even several papers based off of this data set. And I think going forward, cohort study with biomonitoring would be needed just to understand how firefighters have continued accumulative exposure to some of these different concerns and some of these different chemicals. So at the risk of going on for too long, I'd just like to thank you very much. This is our paper, and we hope that you enjoyed having it. Thank you.